welcome everyone. Welcome to the Wasm workshop. As more people are trickling in, just want to give a couple of logistical things first. So the workshop is around 90 minutes long. There's a lot of demos. There's a lot of labs. You are encouraged to follow along if you'd like. However, you can always decide to just listen and watch and then do the labs on your own, at your own pace, at your own time later. Now, for any questions, we have a Slack channel up. Please join the Slack. The channel is called Wasm Workshop. I'm Peter, by the way. With me is Eitan as well. And there's a lot of other Tetrans in the Slack channel as well who will be helping out with your technical questions. So feel free to ask tough questions. We want them. The reason we're using Slack is so we can communicate back to you and actually answer your questions later on, and just in case we can't answer them during these 90 minutes. As I mentioned, there will be practical labs. So you can head out to the Tetrate labs.github.io/wasm-workshop link. So all the labs that I'll be going through are in there. Now, I might skip through a couple of labs because of the time, but everything will be there for you so you can go through at your own pace. All right, so I think we can start slowly. People will probably be trickling in. The academic 5 minutes or 15 minutes, I guess, right? But all right, so what will we talk about today? So we'll start with WebAssembly first. We'll talk about WebAssembly in Envoy proxy. We'll mention the ABI, which is application binary interface standard, and then we'll dive into the Proxy-Wasm and Go SDK. So there will be demos at that point to show you how you can run Envoy locally using the funky CLI. And then we'll already start with creating a minimal Wasm extension. We'll be using Go SDK, and we'll show you a couple of pieces of functionality in the SDK and how to use it. And then lastly, we'll talk about Wasm and Istio. So we'll talk a bit about the history of Wasm and Istio, and we'll introduce the Wasm plugin resource that shipped with Istio 1.12 only like a month and a half or 2 months ago. So it's fairly fresh and fairly new. We'll finish up with Q&A. We'll have dedicated time at the end, but feel free to ask at any point, ask your questions, put them in Slack channel, and we'll answer them. All right, so let's start with explaining what Wasm even is. So Wasm is a portable binary format for executable code that relies on an open standard. So it allows developers to write code in their preferred language and then compile it into a Wasm module. So one thing I want to bring up here is, and that's like, it is a confusion that comes up. You don't write WebAssembly code, right? And there's no relation to any assembler or assembly language either. So you write your code in a language such as Go, JavaScript, AssemblyScript, Rust, and then you compile that code into the WebAssembly modules. So these WebAssembly modules are isolated from the host environment, and they're executed in a memory-safe sandbox called a virtual machine. Now, to communicate, for these modules to communicate to the host environment, they use an API. Initially, Wasm was designed to be run in a web browser. So there's a WebAssembly W3C specification, and it has been implemented in the major browser engines since 2017. Now, the main goal of Wasm originally was to enable high-performance applications on web pages. So for example, let's say you're building a web page, a web application, let's say JavaScript, that uses a lot of either 3D animations or something that's typically heavy and slow to execute with JavaScript. What WebAssembly allows you to do is you can take that code, that 3D computational code, and write it in Go, Rust, or C#, and then compile that into a Wasm binary file. Then you can run that compiled Wasm module in the same sandbox as your JavaScript web application, which means that you can run code written in high-level languages, Go, Rust, C#, etc., on the web in these virtual machines. Now, you can also embed these virtual machines into other host applications and then execute them. And this is exactly what Envoy does. So just a little bit about Envoy for like, if you want like a full Envoy deep dive, I guess, or Envoy fundamentals, we have a free course. We'll put a link in there in the chat for you if you want to go more into details about Envoy specifically. But today we'll talk about the extending Envoy portions, which are the Wasm modules, right? So Envoy is an open source proxy that's written in C++. And there are, in addition to a lot of functionality that's already in Envoy baked in, you also have an option for extending Envoy, right? So then there are a couple of ways to do it. First one is you can write native C++ filters and then package them with Envoy. So this would require you to recompile Envoy and maintain your own version of it. Now, taking this route might not be too practical. Now, it sounds very odd for you to maintain your own version of Envoy just because of the filters you use, but that is an option that you could take. A better one, perhaps, if that's something that's of interest to you, is what you could do is, if you think your C++ filter is something that's valuable for the community, you could always pitch it to the upstream Envoy, to the Envoy maintainers, right? And try to get it included in the Envoy proxy itself. So that way you don't have to maintain your own version of it. Now, the second option is using the Lua-based filters. So there is a filter in Envoy called HTTP Lua filter. And what it allows you to do is to include a Lua script in line with the Envoy configuration. Now, this is a good approach to take if the filter you're creating is not too complex. You can write your Lua script directly in the Envoy YAML config, or you can just point to a script that lives in a separate file. Now, for this to work, if we're talking Kubernetes and Istio, you would have to copy the script to your cluster and then basically make it accessible to the Envoy proxy so they can load the script and they can run the script. Now, the last option, of course, is the Wasm-based filters. And as I mentioned, with this option, you write your filter as a separate Wasm module, and then Envoy loads it and runs it. And this is what we'll talk about today. So what Envoy does is it embeds a subset of a V8 virtual machine. Now, V8 is the name, it's not the version, right? And it's a high-performance JavaScript and WebAssembly engine that's written in C++, and it's used in Chrome and Node.js. Now, a bit about Envoy. The way Envoy operates is using a multi-threaded model. So that means that there's one main thread that's responsible for handling the configuration updates and executing any global tasks. Now, in addition to that main thread, there are also multiple worker threads that are responsible for proxying individual HTTP requests and TCP connections. Now, these worker threads are designed to be independent of each other. For example, a worker thread processing one HTTP request will not be impacted by other worker threads that are processing other requests. Now, in order to avoid any expensive cross-thread synchronization in terms of higher memory usage, each thread owns its own replica of resources, which also includes the Wasm VMs. So what Envoy does is it loads every unique Wasm module, so that's all .wasm files, into an individual Wasm VM at runtime. Now, because Wasm VM is not thread safe, meaning multiple threads would have to synchronize access to a single Wasm VM, Envoy creates a separate replica of Wasm VM for every thread on which the extension will be executed. Now, consequently, every thread might also have multiple Wasm VMs in use simultaneously. So here's just a quick example of how two extensions or plugins. By the way, I'm going to use like extension plugin module some people also use add-ins, I guess, but I would say modular plugin is the right word when you're talking about Wasm, right? Just if I make a mistake, you know what I'm talking about. I'm talking about .wasm file, right? So here's an example of how two modules get loaded in worker threads. So one extension is called addHeader.wasm that perhaps adds a custom header to all the requests. And the second one might be a custom rate limiter we created that's called ratelimiter.wasm. Now, within a single VM, we can also run multiple different plugins, not just one. So there's a Proxy-Wasm API. So I mentioned that briefly. So API stands for Application Binary Interface, and this API describes the interface between the Envoy, between the host, and the Wasm VM. So this interface specifies how to handle proxy events inside Wasm VMs and consequently inside your Wasm modules, or what kind of an API is provided or exposed by Envoy into the virtual machine. So Proxy-Wasm API is fairly low level. So let me open a page and just so you can get an idea how this looks like. So this is the Proxy-Wasm API specification, and these are types of functions you would find in this specification. So it's fairly, like, for me, as soon as I see something like this, right, like UN_T and size T and bool, C++ for me, very low level. But you can see it's fairly low level, right? There's no like a higher abstraction on top of it, right? But this basically in this repo, what you have is it describes how Envoy and the Wasm virtual machine can communicate, right? So if we would look at these functions implemented in the Wasm modules, we would pretty much have to implement all these into in our module in order to work and talk to the Envoy proxy. Now, for that reason, to make the development much simpler, there are 5 language SDKs available. So if you don't necessarily care about all the details of the Proxy-Wasm API spec, which, hint, you shouldn't care about that, right? If you're not writing an SDK yourself, right? So what you should do, for most of us, what we would do is we would just use one of the language-specific APIs that then comply with this API spec. So let me show you the Go SDK spec and how that one looks like. So it's in this repo here, and if we go to Proxy-Wasm, and if we look at the host call, this is where the higher level SDK APIs are implemented. You see that this looks more, I would say, more developer friendly, I guess. You have functions like enqueue shared queue, dequeue, plugin done, dispatch, HTTP call, get response headers, get response body, etc. Right? So it's fairly more high level than the API spec, right? And these SDKs make it much easier to get started. All right, so as I mentioned, I'm not going to go into Envoy too much. However, one of the building blocks that I've already mentioned in Envoy are filters. So these filters can be placed in the request and response paths. So whenever you send a request through Envoy or whenever Envoy sends a response back, these request responses go through the paths of, go through these filters in order, right? An example is a router filter whose job is to route the requests to an endpoint. There's also a statistics filter for collecting statistics about the requests. There's rate limiting filters, RBAC filters, external auth filters, Lua script filters, and so on. Now, one of the filters that can be put in this filter list is called Proxy-Wasm Extensions, so a native Proxy-Wasm extension. The reason I'm calling it native is because it's built in with the Envoy proxy. So its job is just to translate between the Envoy API and the Wasm engine using that Wasm API, that interface. So if you look at the slide, if you imagine the requests coming in, starting at the top. It's going to flow through various Envoy native extensions. And then at some point, assuming we want to load a Wasm module, right, it will go through this native Proxy-Wasm extension, and then it'll call out to the VM, to your extension. The extension in the VM will process the data, it'll do whatever it needs to do, and then it'll return a value saying either continue the execution to the next filter or stop the execution, right? So you can imagine a filter where you check an authorization header, for example, and if the authorization header is invalid, you don't want to continue executing, right? You just want to cancel the chain, right? Or stop the request. Now, in addition to running the extensions as part of the request processing, we also have an option of running an extension as a singleton. So instead of running these extensions or Wasm modules in every worker thread for every request, what the singleton extension allows you to do is so that extension runs per Envoy proxy instance in the main thread. So for example, you could use this singleton extension to, let's say, gather different metrics or data across all the different worker threads. So you can imagine having an extension on the HTTP path, right? So that extension would get invoked every time there's an HTTP request that goes through Envoy. And that extension could like store some metrics, put some metrics on the queue, and that data can then be read and processed from this singleton Wasm extension. And I'll talk about a little bit about queue, and I'll have a diagram on one of the later slides to just show you how this looks like. But the idea here is HTTP, TCP extensions, they're run on every request in worker threads. However, there's also a way to run a singleton extension called Wasm service, and that one runs in the main thread, and it's typically used to collect the data across multiple worker threads. All right, so I mentioned ABI, very low level. It's hard to write extensions directly on top of that. Therefore, we have the SDKs that provide the language-specific implementation of that ABI. So Envoy is unaware of the SDKs. It only depends on the ABI. So it doesn't really matter which SDK you use. So if you ask me which SDK should I pick, well, pick the one in the language you're familiar with, right? You're not going to pick Rust if you don't know about Rust or C++, etc., right? The idea here is that all of these SDKs will produce a Wasm file that can be executed by the Envoy proxy in the exact same way. Now, we'll use Go SDK. I'm not a extremely proficient Go programmer, but it seems like this one was a popular choice, specifically in the cloud native world, right? Go is extremely popular. And the Go SDK is powered by a compiler called TinyGo, and this compiler is used for embedded systems and WebAssembly, right? One note here is that it does not support the use of all Go standard packages. So some standard packages are not supported. And if you go on to TinyGo website, they have like a nice table that actually shows you what's supported and what's not supported. Now, there are three main concepts that we need to understand when we're working with Wasm extensions using the Go SDK. These are the contexts, the HostCall API that we've already saw a little bit, and the entry point. So what are contexts? Contexts are a collection of interfaces in the SDK, and they map to the concept of a virtual machine, and then either one or more plugins or TCP and HTTP contexts. For example, there is a single VMContext in each VM, and these VMs can then host one or more plugins, one or more Wasm extensions. Therefore, we can have one or more plugin contexts defined. Now, having multiple plugin contexts means that we can run different extensions within the same VM context. And this happens when you use the same virtual machine ID. Now, each plugin context then corresponds to an instance of your extension, right? And that extension can either react to TCP context that, or actually TCP traffic that corresponds to a TCP network filter. So that's the filter that handles TCP connections, or HTTP context, which is an HTTP filter that handles the HTTP requests. Just a brief introduction to how this looks like in code. The VMContext interface has just two functions defined: on VM start and the new plugin context function. Now, as these names suggest, the VM start gets called when the VM is created by the host, which is Envoy. And then from within that function, we can retrieve, optionally retrieve any configuration at the VM level, right? Using a get VM configuration host call, for example. But the main purpose of this function is just to perform any VM-wide initialization. Now, as a developer, what you need to do is you need to implement the new plugin context function. And then from inside that function, you will create an instance of the plugin context. So that's what the notation in that interface, if you're not familiar with Go, that's what it basically says, right? The function's name is new plugin context. It takes in the context ID, and then it returns the plugin context. All right, so, the next one was the plugin context, right? Very similar functionality as with the VM context, but this one operates on the plugin level. So the plugin start function is comparable to on VM start that I've mentioned. It gets called when the plugin gets created. From inside this function, you can retrieve any plugin specific configuration, right? Using the get plugin configuration API. We'll show that in an example. And also what you have to do here, at the bottom, there's the two functions, the new TCP context or new HTTP context, and those two have to be implemented, right? And they get called in response to HTTP or TCP streams that happen in Envoy proxy. So if you load your extension, if you load your plugin, and there's an HTTP request that comes in, the new HTTP context function will get called. There's also a couple of other functions here on this interface, functions to set up the queue or do any asynchronous tasks parallel to the stream processing. That's the onTick function. Now, the HostCall API, this is what I showed a bit earlier. So this is the API implementation that actually lets us interact with the Envoy proxy from the Wasm extension. So it defines the methods for reading the configuration, setting up shared queue, performing queue operations, dispatching HTTP calls, retrieving headers, trailers, body from both request and response streams, manipulating all these values, configuring metrics, and more. Finally, the entry point for the plugins, when we talk about Go, is just the main function. Main function is the entry point in Go applications anyway, right? So Envoy creates the VMs, and before it tries to create the VM context, it will actually call the main function. Now, in the typical implementation, what you would do in this main function is you would call the set VM context function, and then pass in your own context structure that you want for your VM to have, right? And the Proxy-Wasm is just the name of that's where all the APIs are available in. All right, so let's start. If we briefly think about what do we need to start, what do we need in order to get started, right? So first of all, you need your code, of course, right? So that's the code that you want to run. That's your idea for your extension, your rate limiter, your header manipulation, whatever you're trying to do, external auth. And then in that code, what we'll be doing is we'll be using the SDK to talk to the Envoy proxy host. So we'll use Proxy-Wasm Go SDK. And then once we've written the code, we'll use a compiler to take that source code in Go and compile it to the Wasm file. So to do this, we will use TinyGo compiler, and that will generate the Wasm file. So the TinyGo has a target called Wasm that allows you to get a Wasm module. So once you have that compiled binary, then you need a way to run it. We'll start with just running it with Envoy proxy directly first, and then later we'll talk about how to run it in Istio as well. So for this exercise, what you need a way to run Envoy proxy with some minimal configuration, right? So we have to have some minimal configuration to tell proxy, hey, here's where the Wasm module is. I want you to load this. I want you to run this Wasm extension. All right, so let me switch to VS Code and the terminal, and we'll create and get started with the first minimal, minimal Wasm extension. So let me move here. I wasn't monitoring the questions. I'm assuming Eitan and others are keeping an eye on that.
Yes, we definitely are, Peter.
All right, perfect. There was a question on Mac. Yeah, you can run this on Mac. Now, the reason I'm not running it on Mac because I have an M1 laptop, and by the time that when I got it, there's issue with running Docker and all those things, and I'm like, you know what? I'm just gonna use a Cloud Shell. So this is Linux, but you can run this on Mac, and I think you can run it on Windows as well, because we do have, at least Funky has support for Windows. All right, and this is the downside of running this in Cloud Shell, is sometimes it just stuff doesn't get installed properly. But anyway, so I'm just installing TinyGo, and this is all in the I think it's called prerequisites, right? Development environment lab, on that link that we shared. So as soon as this is done, I'll go into the Wasm extension. I've already created this folder. There's nothing here. What I'll do is I'll initialize the module, and this is all Go specific. There'll be a lot of Go specific things just because we're using the Go SDK, right? But so let me actually do it without a typo. There we go. So it created this Go mod file, and what we'll do is we'll create a main.go file, and then I'll just copy the code from the lab. So let me zoom in here a little bit, and we can look through this. This might look familiar because this is what I pretty much discussed in the slide. So we have this main function where, something's wrong here. Okay. Main function where we're setting the VMContext. VMContext is just a struct, and we're just embedding the default VMContext here. We have the new plugin context. We're returning an empty plugin context, and we have this new HTTP context function where we're just using log info to log out a message called new HTTP context, right? And then this is how the HTTP context looks like. So let me download the SDK. So Go mod tidy will just go and download the Proxy-Wasm SDK that I'm referencing here at the top. So once this is downloaded, I can then use TinyGo to actually take that main.go file and create a Wasm file out of it. So let's do this. Let's build it. And that's it. I'm not going to open this one because it's a binary thing, right? But this is all it took to create a Wasm extension that logs a new HTTP context message whenever there's a new HTTP request that comes in. All right. So we have this. The next thing that we have to do is we have to create a minimal configuration for Envoy in order to run Envoy proxy. So let's do envoy.yaml and copy this here. Just briefly, I'm going to go through this, but I would suggest if you want to learn more about Envoy, go through our Envoy fundamentals course. So we're creating a single listener. We're listening on port 18000. So this is where we'll be sending the requests to. And this is where we have our filters defined. So we have the HTTP connection manager filter, which is basically accepting requests for all the domains, for all the hosts, right? And it's just sending a direct response. So regardless what we send to it, it will just respond with 200 and with the hello world. Now, realistically, right, this would be more complex, right? If we're talking about more realistic implementation, you would probably have multiple routes here, different clusters, different endpoints, etc. But direct response is really nice for just testing things. All right, and under the HTTP filters, so we have filters, and then we have this HTTP connection manager filter that has the HTTP filter thing underneath. And in this list, we have two filters. I've mentioned the router one, right? So this is always the last filter in the list. And what it does is it just sends the request to your endpoint, right? Which in our case, we don't have it because we're just sending a direct response, right? And then before that, we have the Wasm filter, HTTP Wasm filter defined here. And what we're doing here is we're creating the configuration for our VM virtual machine. We're setting a virtual machine ID. So we're identifying that virtual machine with a string. We're specifying this runtime. There's a couple of other values here, but whenever you're doing Wasm, this is just saying use the V8 runtime, right? And then we're saying, by the way, this is where you can get the code from, right? So we're pointing to a local file name called main.wasm that we just built. All right, so we have this configuration there. So now what we have to do is we have to run Funky. So Funky is a CLI that just allows you to easily run Envoy proxy. So you don't have to deal with Docker images. You don't have to pull different versions, etc. You can just use Funky to run it. So we'll do Funky run -c to pass in the configuration. We'll say envoy.yaml, and I'll just use and to run this in the background. So let's do this. There'll be a lot of log messages here. And this is it. Like, we have the Envoy proxy running. So what we can do now is I can do a curl request to localhost 1800 because this 18,000, because this is what our Envoy proxy is listening on. So let's do this. Let's see what happens. There you go. Boom. Nothing really happened. If you think about it, we got the hello world response. This is the response that we set in the direct response here. But you also notice this new HTTP context. I guess this is the actual message that we logged from our Wasm extension. My_VM, that's the ID of the virtual machine, right? So this is what our extension does right now. Nothing too complex. Also, just quickly, I'm going to run this wasm object dump command on the main.wasm file that was built, and you'll notice that these are the actual functions from the ABI, right? That are implemented inside that Wasm file. All right, so this was the first quick lab, I guess. Let me go to, and I'll do a lot of back and forth from now on. I just want to introduce a couple of concepts first, and then we'll go back to the labs again. So the first set of functionality or features or APIs that I'll talk about next is they are related to manipulating requests and responses, specifically headers, trailers, and bodies of the request, right? So the functions on the slide, I know the notation looks a little bit odd, right? But I was trying to condense it together, right? So you can think of it, if I take the first one, so we have get HTTP, is the name of the function. And then we can have either a request or response. So we can get HTTP request or response, and we can read either headers, body, or trailers. So the combination of the combination of all of those, that's all that you can retrieve, right? So you can get the request, response, headers, bodies, trailers. You can replace those, you can remove them, or you can add them, right? So these are fairly, and then the same thing or similar thing for TCP, right? So you can get, append, prepend, replace the downstream or upstream data. So all of these are fairly straightforward to use. For example, we'll see in the lab, like adding a header, the only thing that you have to do is you provide the header name and a value, right? And then in order to retrieve it, you just provide the name of the header, which value you want to retrieve, and so on. It's fairly straightforward. Now, the next group is a configuration-related API. So there's two areas or places where you can set the configuration at. One is at the plugin level, at the extension level, and the second one is at the VM level. Now, the corresponding APIs are get VM and get plugin configuration. And one thing that I want to note here is that you can only call these either in on VM start if you're retrieving the VM configuration, or in the on plugin start function if you're retrieving the plugin or the extension configuration. Now, in addition, there's also other functionality that's available in the API, things like sending HTTP responses directly. For example, you could inspect the incoming requests, and then if a specific header is set or not, you could just send an HTTP response, and then the request won't even make it to your upstream service. Similarly, you can also dispatch HTTP calls to clusters that are specified in your Envoy configuration. Now, I specifically mentioned clusters. So clusters are one of the building blocks of Envoy that specify a logical group of endpoints, right? So if you want to call based on some condition or logic, you could say, hey, I'm going to intercept this call, and then instead of routing the call where it should go originally, I'm just going to dispatch an HTTP call to a different server's upstream cluster and then do something with that response. Finally, you can also set the property and metadata from the Envoy proxy itself. So I was just Googling here just to show you the page. I move it here. There you go. So what Envoy does is it stores and it allows you to retrieve a lot of metadata from the requests, from the responses, from the connection, right? Different attributes, and all of these things, you can retrieve them, right? So you can retrieve them from your Wasm extensions. Oops, I moved the slides. There they are. All right, well, we're on to next lab, and we'll show the configuration and headers and see how that works. So let me switch to my notes. And this will be configuration and headers. So the first thing we'll do is we'll add an HTTP response header. So we'll create an on HTTP response headers function. And within that function, we'll just add a new response header using the add HTTP response header function from the SDK. So we'll have to create this function. So I'll copy paste it down here. So we're creating on HTTP response headers, and this means this will get called when the HTTP response headers are processed. We'll just log in an entry here to the log, writing to the log. And then we're calling the add HTTP response header function, and we're saying, set the header called my new header with some value here. You'll notice I'm very inventive with my examples and names, but naming is the hardest thing, right, in engineering. So anyway, we call the response header function. We set this header with this value, and then if there's an error, we're just gonna fail. We're gonna say, hey, we failed to add the response header. Just log that out. And then at the end, we're just saying action continue. So this is I mentioned this in the slides, right? So we are the ones who can decide if we want the execution of the filters to continue or not, right? Instead of actions continue, we can say action pause, and then it's going to stop executing the next filter, right? So basically say, nope, you're not going to go forward, right? We're saying action continue here, right? So let me bring this the old funky from the background. And what we need to do is we need to rebuild the extension again. So once that one's done, we will rerun the proxy. So no changes here. And then I'll just move this a little bit higher. And this time we'll make the same request, but I'm just adding -v to get more verbose output. We're saying localhost 18,000. Boom. Now we still get hello world back. It is a 200, we get it back. Notice two log entries here. The first one is from the previous one that says new HTTP context was created. And the second one was, hey, on HTTP response headers was called, right? Also down here in the response headers, you'll see this new header with some values here. Now, hard coding stuff is never good. So let's see how we can read read some values from Envoy configuration, right? So let's see how we can do that. So we'll go to the PluginContext first, and over here, I'll just add the additional headers map, and you can think of just key value pairs here and the context ID. And then in the new plugin context, what we'll do is instead of returning an empty struct, we will set the context as well as initialize this map of additional headers. So additional headers is where we will store any headers that we read from the configuration file. So this one will be a little bit verbose, but just bear with me and I'll tell you exactly what I'm doing here. So on plugin start, what we want to do when the plugin starts is we want to call this function called get plugin configuration. So we want to read the plugin configuration. We get the data. So the function returns a data and an error. So if there's an error, we will show that message. If there isn't an error, we're using this fast JSON parser. So this is just a library. And the reason for it is because TinyGo does not support JSON library. The big JSON library from the standard Go package, right? So we're using this fast JSON, and this is all like fast JSON code for parsing the data. And then over here, this is what's important. This is what applies to us. So we go through all the values in the JSON configuration, and I'll show you how the JSON configuration looks like. So the JSON configuration will look like this. I just create a new file here. Temp JSON. So this is what we'll be setting in our Envoy configuration. So we'll just say header 1 equals some value and header 2 equals second value. So this is what we're reading in over here. And we're saying the additional headers set the key and value to whatever this is, right? So whatever we read in, whatever we parse, set it on the context, on the additional headers that's coming from the plugin context. Right? And then we're just saying plugin start, status okay, everything is good. So once we have this, we also need to pipe the additional headers through to the HTTP context. So we will add this variable here. And then in the new HTTP context over here, what we'll do is I'm just going to copy paste to replace it. And we'll add the context here. So what we're saying is we're creating a new HTTP context with the context ID, as well as the additional headers that we got from the plugin context. And the plugin context is where we actually read the data and parse the configuration. All right, and then in the add response headers function on HTTP response headers, this one, I'll just replace this with some code. Let me make this easier to read and look at, and we'll go through it. Same log entry as earlier. We're just going through all the headers that we read from the configuration, and then we're calling add HTTP response header, setting the key and the value. If there's an error, this time we'll return action pause. We'll say, oh, something's wrong. Stop executing anything after this, fail. If there's no errors, we'll just log and say, hey, we set this header with this key and with this value. So that's all it takes. So let me rebuild. I mean, it's not all it takes, but it's very close. Go mod tidy to download the packages, and then we'll build it. What we also need to do is we need to set the configuration in the Envoy file, right? We need to actually say, hey, this is what I want you to read, right? And we'll get the configuration here, and I'll just indent it with the VMconfig because that's where we're setting it, right? So we're saying configuration, this is the value of the configuration. So we have the two headers, header 1, header 2. That's the configuration for our plugin. So let's stop executing Envoy and restart it. We've already rebuilt the extension. All went good here. So this time, if we make a request, let me clear the screen. So if I make a request to localhost 18,000, now this time, if you notice down here, all the responses are the same, right? Let's look at the logs first, right? New HTTP context, then we got the on HTTP response headers, and then the actual two header values that we read from the configuration file, right? So we set the two headers, And you can see the two headers that were set down, down there. All right, so let's go back to the slides. So the next thing is sharing data. And this is a way for you, like, you can run the plugins within the same virtual machine, right? So that's that VM ID that I had set in configuration. And there are APIs available that allow us to share the data between different plugins. Now, the set and get shared data functions, they allow us to store key value pairs in a space that's then shared between plugins that are running in the same virtual machine. Now, you will get an error if you try to call these and there's either no VM set or they're not running in the same VM IDs. So here's how it looks like. So whenever you want to communicate with other VMs, and you could do this to aggregate shared data stats, for example, right? You could use this concept of shared data. It's a key value stored, share across all the VMs that have the same VM ID. So that means if we look at this example, we have the hello.wasm and buy.wasm. And those two extensions have the same VM ID set. It's set to foo, right? Meaning they can access the same shared data instance and they can share the data. Now, the third one here, which is also called Hello Wasm. However, this one is running in a different VM. It's called VM ID is set to bar. And this one does not allow, you can't share data between the other two. So there's a lab here, but for the sake of time, I'll skip the lab on sharing the data. You can still go through it on your own time. I want to get to the actual, we'll go through the metrics data probably, or one of those, but I want to get to a point where I talk about Istio as well. And then if we have time, I can come back. The next way to share the data is using the queue. And this is a bit more, looks a bit more complex, right? But the idea here is, this is where we would have a singleton wasm, right? Something that runs in the main Envoy thread that collects the data from the worker threads, right, that are running in different like worker threads, right? Now each queue, you can use the queue to do that, right? So each queue gets a name and an assigned VM ID to do the queue operations on. So the singleton wasm service is the one that should create the queues, and that's on the main thread. So the calls aren't blocking any processing of either HTTP or TCP streams. Now, this diagram shows the singleton wasm extension that was loaded in the VM that's called foo. So it has a VM ID of foo, and there are two plugin configuration provided, and the two wasm services are created that correspond to PluginContext 1 and PluginContext 2, and that's for those two Wasm extensions. Now, these plugins then register a shared queue by calling this register queue function with the HTTP and TCP arguments, and calling the register queue will then actually trigger the creation of these two queues. Now, the plugins, the contexts are notified through the onQueueReady function whenever an item gets added to the queue. So this looks complex. We don't have a lab on this one per se. However, we can share the link to the Go SDK. And if you look into Go SDK, you'll see how this looks like, right? And the reason is it's just not enough time to go through all of this. And the actual difference here is the difference between running a singleton VM versus running a singleton Wasm extension versus running a non-singleton extension is in the way where they're configured in the Envoy configuration, right? For the singleton one, you would configure it under bootstrap field, versus for HTTP or TCP extensions, you configure it in the filter itself. All right, so the next part of the SDK are metrics, and these metrics, the functionality here allows you to create counters, histogram, gauges. There's functions called define. There's functions called define either one of these three metrics, and then they have on that function there's a way to increment, add, and record the values. So let's go through the adding metrics lab quickly. So I've skipped one in between one of the labs. So I'm in the adding metrics lab. So what we'll do here is if I go to main.go, we'll go to the plugin context and we'll just create an instance of a metric, which is a counter. We're just going to call it a hello header. What we want to do is we want to inspect incoming request. And if there's an incoming request with a header called hello set, what we'll do is we'll just increment that counter, right? So let's create this counter in the instance of it. We can create it in the new plugin context. So over here, what we'll do is we'll just say hello header counter, and we'll call the defined counter metric on the Proxy-Wasm, and we'll say the name of our metric is hello header counter, right? So let's do this one. And then we also need to pipe it through our HTTP context down here. And then we also need to set it in the new HTTP context over here. We can say HTTP hello header counter. It's coming from the context, from the plugin context, and it's called hello header counter as well. Now that we have this all piped through, what we can do in the request headers. Now notice we were doing response headers before. Now we'll do request headers because we want to read the request headers in to see if there was any header called hello set. So what we're doing here is, let's clean this up just a little bit. So we're logging in, logging out on HTTP request headers. We're trying to retrieve the header called hello. Note that we don't care what the value is. We just care that there's a header called hello set. If there's an error, we'll just ignore it, right? We'll continue. We're not going to fail. We're just not going to increment the counter. Now, if the header is set, we're calling increment function on this hello header counter, and we're incrementing it, and we're also logging out saying, hey, we incremented this counter. All right, so let's rebuild this. Tiny go. Oh, I missed something. 46. Line 46. There it is. Did I miss one, or do I have an extra one? I think this should be fine now. Yep, I had an extra parentheses there. All right, so let's bring Envoy in foreground, and I'll just rerun Envoy again. There you go. And now if I just make a request, new on request headers was called as well. However, it didn't increment the header because we didn't set the hello header. Now if we set something, a header called hello blah, if we run this, oops, what did I miss? Oh, there we go. It's down here. I thought it wasn't happening. So new HTTP context was created on HTTP request headers was called. This is where we check for the presence of the hello header, and then we're just incrementing it, right? Now, in addition to this, in my Envoy configuration, what I did is I also exposed this administrative interface. So this just allows you to get access to metrics and different other administrative stuff about your Envoy proxy. And one of those things is Envoy also like exposes a lot of metrics and statistics, right? So you can get a lot of them by just curling against 8001 here and saying stats Prometheus. And just Prometheus is just saying, I want stats in the Prometheus format. Now, if I run this, I'll get all the stats that Envoy is collecting, right? There's a lot of them, right? There's a lot of them. So let's do this. Let's curl it, but let's also grep for a hello, right? And you'll notice there's the hello header counter with the value of 1. So if you would make a couple of requests here, just making a couple of requests. And then if we rerun this, you'll notice that the header counter is now to 6. So each time there's a header on the incoming request called hello, we're going to increment the counter. So this is just an idea to show you how you can also configure and create new metrics. All right, so let's go back to slides. And the next thing we'll talk about is how to deploy. So all up till now, we're just running no Kubernetes clusters, no Istio. It was just pure Envoy, right? And next thing we'll talk about is how to deploy these Wasm plugins into your Kubernetes clusters that are running Istio and run them next to your workloads. So I'll talk about this new Wasm plugin API, but let's do just a quick look into history before. History of Wasm in Istio and Envoy specifically, right? So before Istio 1.4, that was November 2019. So there was no mechanisms to run plugins, right? And at that time, Istio was also maintaining their own fork of Envoy proxy. Remember what I said on like second or third slide? It's very painful to maintain your own build of proxy. For that reason, there was very strong motivation on the Istio side to have like a good plugin system like Wasm, right? Because that reduced the burden on Istio maintainers, because they had to maintain their own complicated Istio-specific Envoy extensions and specific Envoy build, etc. It was just a big burden, right? And if you have a good plugin system, you don't have to maintain your Envoy build, right? At that time, Istio was using Mixer and Mixer plugins, and those allowed for like custom policy and telemetry support, right? Now, Istio always wanted to provide a platform that would allow, now in addition to helping with their maintenance and with like functionality that's inside Istio, they also wanted to give developers a way to build their own extension, right? They focused at that time on this extension model that was called Mixer, and as I said, this was you could use Mixer to like enforce different auth policies and then collect telemetry, for example. And in this model, what happened is that Envoy proxies would actually call out to Mixer. Mixer was like a separate component that was running in Istio. They would call out to that component before making any requests, just to do any precondition checks to say, hey, can I call, like, can workload A call workload B? Yes or no? Tell me, right? And then they were also calling out to Mixer component after each request was completed to report any telemetry, right? And this model led to inefficiencies in the way the resources were used, and it impacted latency and resource utilization and so on. Now, on the other hand, the extensibility in Envoy, as mentioned, right, it relied on developers knowing how to write extensions in C++, right? So if you wanted to build your extension, you would have to build it in C++. You would have to then bundle it together with the Envoy proxy. And then if you wanted to push out an update to your extension, you would actually have to go and restart all the instances, replace the new binaries. It's not straightforward, right? Now, some of the performance-sensitive Istio features, such as policy checks, specifically the RBAC filter and JOT authentication, the JOT authentication filter, those were already implemented and part of Envoy. So those are C++ extensions that are in Envoy, built with Envoy. However, there was a still desire to converge on one extensibility stack that allowed for decoupling of Envoy releases from the extension ecosystem and basically enabling developers to use something other than C++. I don't have anything against C++, but there are other higher level languages that are really nice as well. And it also, they wanted something that would let Istio also roll out any new features and capabilities whenever they wanted, right? So they don't have to worry about Envoy builds or Istio builds. I have my own plugin, I can upload it, update it, deploy it whenever I want to. I don't want to depend on anything else. So enter WebAssembly. Now the work on WebAssembly support and Envoy started back in 2018. I actually found the GitHub issue as well, and it was completed and it was included in Istio 1.5. So this release, the 1.5 release, included a new model for extensibility that was using WebAssembly. And the need to run separate Mixer component was also gone, which simplified Istio deployments. And this release was also when the generic ABI was introduced, as well as the C++, Rust, and AssemblyScript SDK. Now, the Istio stats, the metadata exchange, and some other functionalities were also recreated as Wasm plugins. And in order to deploy these plugins, you could use a resource called Envoy filter. Now, if you've ever used Envoy filter resource before, this is an Istio resource, you know that it offers a very, very light or almost none of the abstraction over the Envoy configuration, right? Which effectively means that you had to know all the details about the Envoy proxy, the details about the API, and it was just very hard and not straightforward to use it. So then to have Envoy load and user extensions, you also had to figure out how to bring that Wasm module inside the same pod where the Envoy proxies are running so Envoy could access it, right? So that was one way. Like you've noticed we use the code local file to reference to a local file, right? So if you're talking about Kubernetes and Istio, you have to figure out how to get that Wasm extension in. Now, another option here was you could specify an HTTP location. So you could upload your plugin somewhere on an HTTP location and then cross your fingers that it didn't fail. Now, the reason I say cross your fingers that it didn't fail is because there was a bug in Envoy where Envoy could not recover for any fetch failures. So if your proxy failed to fetch the plugin, it just wouldn't work. It just wasn't production ready. Now, an improvement came in 1.9, and this improvement is, what happened here is the Istio agent started to intercept the Envoy filter resources, and then it started fetching the binaries on behalf of Envoy, and then loading them into Envoy as a local file, right? So Istio agents runs in the same pod as the Envoy proxy, right? And then that's the binary, or that's the module component that actually downloaded the Wasm files and then loaded it as a local file inside the proxy. So this resolved the fetch failure issues from 1.5. However, you still had to use Envoy filters, right? And you had to host the binary somewhere as well, right? On an HTTP location. Now, that's why in Istio 1.12, the Wasm plugin API was finally introduced. So no need to use Envoy filters anymore. We can now use a dedicated Wasm plugin resource. So what does this Wasm plugin resource allow us to do? So it allows us to first select or use the selectors using the labels, right, to specify the workloads in the cluster we want to deploy the plugins to, right? So the one on the slide here is saying, hey, I want this Wasm plugin called Hello World Wasm, right, to be deployed next to all the workloads that have the app Hello World label set. That's it. That's easy. So you can target any workload in your cluster pretty much. Then the second thing is you don't have to use the HTTP location anymore. You can now host your Wasm binary on any OCI compliant registry. So what Istio agent does, it fetches the Wasm extensions from an OCI registries. Now the HTTP locations are still supported, of course, and so is the local file. Now, so how does the Wasm development workflow look like right now if you're using Istio, right? So you still write your extension in your preferred language, whatever that is. You still have to build the Wasm file, so no changes here. However, steps 3 and 4, this is like really awesome. Like when I first saw the Wasm plugin, this was like, oh yeah, this is awesome, right? So what you can do now is you can literally use Docker build to build your Wasm extension as a Docker, as an OCI image, and then push that OCI image to any OCI compliant registry. So you can just do Docker build, Docker push, and then use the URL for your repository for that image in the Wasm plugin resource and say, hey, here's where my resource is coming from. If you see the URL portion on the slide, like it's in this registry, this is the name of the image, this is the versioning. So you can treat your Wasm extensions as you treat your Docker images, right? You can also set the plugin configuration, by the way, in the Wasm plugin resource as well, right? So all of this was abstracted out, and you have to say that this is much easier to read than all that Envoy configuration that we saw earlier, right? Now, the way you build the image is extremely simple. You don't have to like understand the OCI image spec. You can just create a unique Docker file, and that Docker file is the same for all Wasm plugins, and then just use Docker to build the image. It's very easy. All right, so let's go and let's look at this lab. So we have, I think, 20 more minutes. So let's go through the Istio lab. Istio Wasm plugin, that's what it's called. So the first thing that we need to do, and I'll keep the same, I'll use the same extension, right? This is the same thing, no code changes here. What I will have to do is I will create a file called Docker file. So if you've done any Docker, you're familiar with a Docker file. And now let me copy paste the Docker file. That's it. That's pretty much it. You have to create a Docker file that is starting from scratch. And what we're saying is, yeah, let's just copy this main.wasm to plugin.wasm inside the image. That's it. Don't have to, there's nothing more to the Docker file here. That's the only thing. Now we also have to build the Docker image, and I'm trying to find the name of my repository. That's what I'm doing right now. And hopefully I'll find it soon. There it is. Okay. So this is the name. I'm just going here. So this is the name of my repository, right? You could have hub.docker or whatever you're using, right? Where your registry is. This is the name of my repo. And then I'll just do, let's call it Wasm V1, right? That's what we have in the lab as well. So from within this folder, Wasm extension folder, this is where my Docker file is, right? This is where my Docker file is. This is where my main.wasm file is. Just say Docker build -t, provide the name. So I don't have to retag it again. And then just do dot, right? Dot, because this is our Docker build context, right? So let's do this one. And of course, I have to click authorize here. Yes, Docker CLI, exactly. I just glanced at the chat. Yes. It's a, so there's a specific spec that OCI, so this image follows the OCI spec, right? So that's how it knows how to do it, right? Yes, the filter, yeah, you are basically pushing the filter to the Docker image registry. That's what you're doing. So we're creating an image. So we built an image. With this Docker file that just copies this main.wasm. Oh, let me stop Envoy here. Copies the main.wasm to the plugin.wasm. We just build that image. So if I do Docker images, I have this image here that I created 40 seconds ago. And then, like what you would typically do anyway with your Docker images, you just say Docker push, name of the image. That's it. Pushed, right? Now, if I would go to, I just open another window here, and I'll show you my registry. So artifact. Yeah, this was like a mind-blowing. This is like a game changer, you know, for Wasm extensions, because you don't have to worry where the thing is coming from. It's already there. So Peter's repo, Wasm, updated just now. Let me zoom in here so everyone sees, right? V1, right? That's the tag. That's how I label the thing, right? But that's the image, right? It's in GCP's registry. It could be any other registry. That's, I think most of them are OCI compliant, right? So you could push to any of them. All right, so we've pushed this. It's in our registry. And now what we have to do is we have to create, and by the way, I do have a Kubernetes cluster running with Istio installed. If you're trying this out, make sure you install the latest Istio 1.12, right? Or newer. I have Istio running demo profile. Shouldn't really matter, right? So I have that running here. So what I'll do next is we'll create the plugin resource. We'll call it plugin.yaml. And we'll copy the contents, and we can go through the contents. I'll have to update them anyway. So extensions, Istio V1 Alpha, kind Wasm plugin. So that's the new API that was added. calling it Wasm example, deploying it to the default namespace. We will deploy the HTTP bin, by the way. So let me actually deploy this. Let's deploy this one first. We'll deploy the HTTP bin, just some workloads, right? Doesn't really matter. And then down here, I have to reference the built image, right? So we're here. Notice this prefix with OCI : // and I'll just do this here. And that's pretty much it, right? You're saying this is the plugin. It's packaged in an image, OCI compliant image. Here's the configuration for my plugin. Some value one, another value, very inventive, I know. And then deploy all this to all the workloads that have the app HTTP bin label set. All right, so let's deploy this one. Kubernetes apply -f plugin.yaml. Wasm example was created. We can do describe Wasm plugin. Oops. Describe Wasm plugin, Wasm example. Typo. Right. That's how it looks like. This is our URL. These are our match labels. This is our config, and all the other Kubernetes goo. Right. So once we have this, the next thing that I'll do is I'll just deploy HTTP bin, and this is just it's from the lab. It's going to be a lot of YAML, but there's nothing really special here. It's just a service account, an actual service, a deployment, and that's pretty much it. So let's do this one. All right, so let's look at the pods. So they are being initialized. Make sure you have your namespace labeled for injection, right? Otherwise, you're not going to get that second container in that pod. Let's do this. Take a little while. All right, almost there. There we go. 2 out of 2. It's running. All is good. And just to test this out, I'll just create a curl container and get a shell inside the cluster, so I can send curl requests to the HTTP bin, and we can actually try and see our extension, our super duper extension in action. Yeah, so HTTP bin filter. Yeah, so HTTP bin is just a workload, right? But yes, the Wasm extension is installed inside the Envoy sidecar, so not the Envoy ingress. Well, you can target the ingress if you want to, right? You can say Istio, right? Whatever ingress gateway, right? If you want to deploy this Wasm next to workloads with this label, right? All right, so let's do .h, and then we'll do hello something. So we're just calling something HTTP bin. So we're inside the cluster calling out to the HTTP bin workload, and we're saying give us back the headers. So over here, up here, you'll see header 1, some value, header 2, another value. This is coming from our plugin.yaml, right? So it's coming from there. If we would do, let's say, Wasm workshop, hello world, right? I'm going off script now, so I'm thinking how all the different ways that this would fail now. So let's see. Let's get the terminal back here. If we say H, might take a little while for the Istio agent to re-download the thing. So let's do HTTP bin 8,000 headers. If it doesn't work, it'll eventually work. Oh, it's still up. Let's see. What's happening? It is running. Okay, let's do this guy. Of course, I had to go off script. So how to deploy a singleton Wasm? That's a good question. I don't know the answer from the top of my head. It might not be supported yet, but we'll definitely have Takeshi or someone answer that. So something. Yeah, I think it hasn't downloaded it yet. Let's just do this for now. Because I went off script, of course, I had to go off script. That's what I always do. But anyway, so does the Wasm plugin figure out if it's a singleton HTTP filter? Yeah, so I mean, from the Wasm plugin itself, like from the code itself, it doesn't really matter, right? I think I would say for right now, I think only like HTTP TCP filters are supported, I would say, but we can double check that. I'm not entirely sure, not 100%, but oh, I know why it isn't working, because I messed up my labels here. Duh, that's why. That's why it didn't work. Yes. Selector, because I messed up my labels. There you go. It should be now. Yeah, we'll answer the singleton thing. I have to look it up. I'm not exactly sure, but from like implementation wise, it's the same. Like you could have the same Wasm file. It's just a matter of where it gets defined. That's the only difference in the configuration, but I'm not really sure if it's already implemented or not. Wasm plugin. They're not mentioning anything in the docs, so I would assume it's not implemented yet. There are ways though where you can specify like the different phase in the filter chain where you want to implement, like where you want your plugin to be placed, but there's nothing about singletons yet. So I'm assuming that's going to come soon. Let's do this again just to show that curl HTTP bin 8000 headers. Hello, blah. There we go. Finally. All right. I had a typo here before in the label. That's why it didn't work. But you see the Wasm workshop hello world is there, right? And the request work as well. And then the last thing that I want to show is, so let's look at the pod here. And I'll do exec HTTP bin Istio proxy, and I'll just run curl against localhost 15,000 / stats Prometheus. So that's the same thing we did before. And I'll grep full hello. Prometheus typos. There we go. Hello header counter is set to 1. I called it once. If we would call it again, right? So HTTP bin 8000 h hello. Oops. Hello, blah, headers, right? Let's call it a couple of times here. Exit. Let's grep again. You'll see it's 6 now, right? So what you could do here is, now we're in Istio, right? And you could do it outside of Kubernetes cluster in Istio as well, of course. But you can imagine now going to like Grafana, and then you could create your own graph that includes your own metrics. All right, so what's next? Image pool secrets. So that's something that it is documented in Istio documentation. However, it's not supported yet. So I don't know when this is gonna come, but what this will allow you to do pretty much is have private Docker registries, and then provide an image pool secret, same as you would do it in like vanilla Kubernetes, right? You create a secret and then refer to it, and then it will allow you to push your OCI or your Wasm extensions to private registries. Also, first class Wasm image cache support in Istio, right? And then I'm assuming singleton is the next thing as well that I should have on this slide. So we have a couple of minutes left. Questions. I see a lot of questions. We'll go through them as well. I want to mention a couple of upcoming events that we have in like the next couple of weeks, and those will be Istio 0 to 60, and we're running 2 of them. One is going to be PST zone. The other one is IST friendly zone. And these are just workshops to get you up to speed with Istio if you're not familiar with Istio. And then finally, I just want to thank everyone for taking the time, for joining, for participating in the chat, asking. I see a lot of questions there, so that's great. We'll have the slides. We'll create a PDF of the slides. We'll basically let you know on the Slack. I don't know where we'll put them yet, but you'll get access to them. Also, for more learning, for more education and everything, you can head over to academy.tetrate.io. We have free Envoy course. We have free Istio course. So that will keep you busy for at least a couple of days. And there's chock full of practical labs that you can go through. We also have a certified Istio administrator by Tetrate option, where you can get certified Istio certification. We do almost weekly, I would say, but not really. We have a live stream called Istio Weekly on our Tetrate YouTube channel. So join that. We talk about various different topics, Envoy, Istio, service mesh related. And then finally, just link to the labs again. I don't know, Eitan, do you want to add something before we close this out?
No, I really enjoyed watching you demo all these features. It sounds like it's really hitting home in terms of people's needs to have a simpler way of deploying these extensions. So I'm kind of eager to see what people do with them. I want to remind everyone that the Wasm workshop channel in Slack is long living. So that may end up where we post that PDF and follow up on questions. So it's not going to disappear after this workshop's over.
Yes, yeah, and feel like I'm fully expecting everyone to go through the labs. I mean, go through them on your own. Like, I know like 90 minutes is not enough, right, to go in depth and all the questions that you have. But if you're going to go through the labs, if you have any questions, any feedback, please, like Wasm Workshop channel or the Wasm Workshop, the pages, the GitHub repo is also public, right? So you can always go and log issues there if you find something that's wrong, there's a typo, like something doesn't work, or if you want to contribute, feel free to like send a PR. But in any case, you can, we'll go through the questions again, at least I'll go through the questions again, try to answer them. We'll tag other people. Like I mentioned Takeshi, right? Takeshi was actually the one who worked on the Wasm plugin functionality, right? So we have the creator, I guess, or a developer that worked on this in case you have any more in-depth questions about it. Yeah, so thanks again. And I hope you'll join us either Istio Weekly or Istio 0 to 60 workshops or any other workshops that we run in the future. So thanks, everyone, and we'll chat later.